Hello everyone, welcome to my channel. In this video, we will be learning about Jetpack Compose. What is Jetpack Compose? Jetpack Compose is a modern toolkit for building native user interfaces in Android. It enables developers to construct UI entirely using Kotlin, which eliminates the need for XML layout. In later part of this video, you will see how using Jetpack Compose simplifies the UI and the development process. Before we dive into Jetpack Compose, let's look at how UI were constructed using XML layout. With XML approach, we define step-by-step process to create and update the UI. For example, this is an XML code for creating a button. Here we are explicitly setting properties like text, text size and text color, and we are also defining its placement, that in the layout, that is where this button should be on the screen. And further, we also had to manually set event listener to handle user interaction, and when the UI needs to change, then we would manually find the view by using an ID. So in this case, we are finding the button using this ID, and then we are setting different properties on this button. So in this case, we are setting on click listener to this button, and whenever this button is clicked, we retrieve text from this amount edit text, and then we apply that text to this amount text view. So this is how UI were created and updated using XML. So this approach require us or developers to manage the state and its update by ourselves. On the other hand, Jetpack Compose uses declarative approach, which means you describe what the UI should look like rather than providing step-by-step process to construct it. So think of Jetpack Compose like it's drawing a picture on your app screen. In this picture, if you tell Compose you want a text, then Compose will draw that for you. Now, if you want a button, you just tell Compose you want a button, then Compose will create that for you. And if you decide to update or increment this number when the button is clicked, then Compose would also increment that number for you. So developer does not need to update the view manually. Compose would update it for us. This is a simple illustration describing how declarative UI works. Now to dive deeper, let's go to Android Studio. In the simple illustration I mentioned, when we instruct Compose to create a text, then it would create that text for us on the screen. So at that time, you may have wondered, how do we tell Compose to create a text? So for that, there is a special function in Compose called composable function. And first, to understand composable function, let's first create normal Kotlin function. Let's call it function count. And this is a normal Kotlin function, but if we annotate this with add composable, this function now becomes a composable function, and this composable tells the compiler that this function is now ready for creating UI. So through this function we tell Compose to create UI. And also notice there is a yellow line under the name of this function. If we hover over it, it will say that composable function should start with an uppercase letter. So replace this with an uppercase letter, and the yellow underline would go away. So composable function should always start with an uppercase letter. And also the name of composable function should not be an action verb. Since count is an action verb, let's append this with screen, and we avoid action verb naming for composable function because composable function are meant for UI creation. And now let's create our first UI. So let's now tell Compose to create a text for us with the string hello world. For that, let's use text composable function and let's pass in hello world. Now through this function we are telling Compose to create this text, and Compose will see this function and it will create this text for us on the screen. Remember how we could preview the user interface in XML before actually building the app. Similarly, in Compose we have the option to preview the UI. To show the preview of this composable function, first we need to create a separate composable function. Let's call that function count screen preview. Inside this function, we need to call another composable function which we want to preview. So in this case, we are calling this count screen composable function which emits a text on the screen. And finally, we need to mark this composable function with a preview annotation, and this annotation will allow us to preview the UI that we created, which is this count screen. Now to see this preview, you need to go here and select this split option. Once you select the split option, you will see the preview on the right side. Here you can see a text with a string hello world, and which is not that visible since it does not have any background. Now to provide background to preview, we need to pass a parameter to preview annotation. Now if you go and hover over this preview annotation, you will see different parameters that we can pass here. So to provide background, there is parameter called show background which takes in a boolean. So let's just pass that here, show background and equals to true. Now you can see a white background and the text clearly. Now if you change this string to, let's say, hello Alice, then this preview will automatically sync with this text or this UI. If you want to see the device preview like in XML, you would need to use another parameter which is called show system UI and pass true as its value. So let's do that. Show system UI, pass true as its value. Let me zoom this preview out. Now you can see the text on the device display similar to what we see on the XML preview. Now you can try different parameters and see the effect it has on the preview. And this way, as we build our design using compose function, we can continuously preview it to ensure that the design is being developed as expected. So that was a basic intro to preview annotation. Now let's add a button to this composable function, and this button has an on-click lambda and a content lambda, and inside this content lambda you can add other composable function based on your design requirement. But for this button, I will add a text. I'll add a text and I'll add count as its string, and since we added this, the preview has also been updated, and as you can see, this count button is above this text. So this brings up the topic of layout arrangement. In XML, we used constraint layout, linear layout, and other view groups for arranging the views on the screen. So in Compose, we have column, row, box, and varieties of other layout composables for arranging and structuring these UI components. So in this composable function, let's use column composable layout, and let's place this text and button inside this column layout. Now as you can see, the button is now below the text. So let's add more text to see how column layout these elements. Let me copy and paste this to this to 3, this to 4. Now as you can see on preview, column is stacking these elements vertically one below the other, so column stacks elements vertically. Now let's remove these extra elements. Let's get back to our main design. Inside the button we have this on click, and this on click has a lambda, and the code inside this lambda is triggered whenever we click on this button. So let's update the text when the button is clicked. But how do we do that in Compose? In XML, for updating the text we used ID, but here in Compose we don't have ID. So instead we can use variable to update the text. So I will create a variable called counter, and it set its value to 0, and let's replace this hello Alice with this counter. So let's convert this to string, because text only takes string, and inside this on click, let's increment the counter value by doing counter plus plus. Now whenever the button is clicked, it should update this counter variable. So now let's run the app. So, and as you can see in the emulator, we are not seeing this count screen UI. So we are not seeing this because we have not called this composable function from our main activity. So let's go to our main activity. So to navigate to main activity, go to the left side of Android Studio, and then there you will see the project structure. If you can't see this project structure, then it must be hidden. So to show the project structure, go here and click on this folder where it says project, and once you click on it, you'll probably see an app folder, and then click on it, and then you will see this Kotlin plus Java or just Java. Double click on it and then find your package name and click on it, and then you will see your main activity. So double click to open this file. So this is your main activity in Compose. This main activity class serves as an entry point for this application. So when you launch your app on the Android device, the Android operating system will look for this class and execute the code so that the app can start its functionality and also display the user interface. And this main activity class extends component activity, which is a base class for activities in Jetpack Compose. And this component activity also provides lifecycle management and other features required for Compose based application. And inside this main activity class, you can find this onCreate method, which we are overriding from this component activity class. This onCreate method is called when the activity is first created, and it's where we initialize the activity and call composable functions to set up the user interface and prepare any data if required. And inside onCreate function, we need to have this set content, and this set content is a compose specific function which defines the UI content of the activity. This is also the place where we specify our root composable function, or called the main composable function. Inside set content, you can define your layouts, theme, navigation, and the UI. Here we have this compose intro theme, which is a composable function that provides themes and fonts for the application. So we are adding this inside set content. And inside compose intro theme, we have this surface composable function, which is a container where we can create other composable function. And we are passing color and modifier to this surface composable function. The color gives background color to the surface, and modifier is an object for styling composable. So for surface, we are providing fill max size, which means that this surface will take the full size of the device. And inside this surface, we are calling another composable function called greeting. And if you command click on this greeting, you will see that this greeting composable function is creating a text. So this greeting function is what we are seeing on this emulator. To build the app with the composable function that we created before, we need to replace this greeting function with our count screen function. Let's run the app. Now on the emulator, we can see the UI we created before. Let's head back to our count screen function, and in this function we have a text that displays the counter value and a button that increments the counter when clicked. So the behavior we want from this function is that when the button is clicked, it should update the text with the incremented counter value. So let's go to the app and check that behavior. So let me click on this button. So I'm clicking on this button, but as you can see, the text is not updating. So let me do this. I will add a log statement on this on click to check if the counter is updating or not. So counter, and then counter.toString. Now let's run the app again. Let's zoom in the emulator. Oh, and also open the logcat. So the logcat is on the left, on this left side of Android Studio. its icon has the face of the cat, and if you don't see this icon here, you can open logcat by going to view, tool windows, and then you can find the logcat here. So let's click on this and open the logcat. So if I click the button again, then you can see the counter value incremented here. If I click it again, it should be 2. So if I click it again, it's incrementing by 1, so it's 3 again, so 4. So if I click multiple times, it will print the count value here. So from this we know that counter is updating but the text is not updating. So what could be the reason? So the reason is this counter is a local variable, and in Compose, to update the data or state when some event occurs, like click events, we need to use states. So in Compose, states triggers recomposition. And what is recomposition? We'll dive deeper into recomposition in following videos. But for now, recomposition simply means calling the composable function again with new data. So what does that mean? In this case, it means that we need to recompose this composable function again with new counter value. In Jetpack Compose, we don't directly update views like we did in XML. Instead, we use state variables to update the underlying data, and then the UI will automatically reflect those changes through recomposition. So in our scenario, when we assign counter as a state variable, and if we update this counter with a new value, then any composable function that uses this counter variable will reflect that update. So let's change this counter from local variable to a state variable, and to achieve that we need to use a function called mutable state of, and inside here you can pass any value. So I'll just pass 0 here because we are using 0 before. And now updating this to a state variable will introduce some error. First, this counter now cannot be incremented directly because this is not an integer now, it's a state variable. So to increment this, we need to access the value property. So let's update every counter to have access to this value property. For that, just do dot value and do this to every instance of this counter variable. So dot value also here. So now that error is resolved, and there is another error here, but we'll come to this later. We can still run the app with this error. So let's just run the app. So now since we are using state variable, the text should update, right? So let's check that. As you can see, the text is still not updating, but why is that? So the reason behind why the text is not updating is that when this button is clicked, we were updating this counter state variable, and when this counter state variable updates, it will trigger a recomposition. That means this whole function is called again, and every time this function gets called again, this counter state variable value will reset to 0. So that's why no matter how many times I click on this button, we were always seeing value 0. And to avoid that, we need to preserve the last value, that is the incremented value. And for that, we need to use a composable function called remember. And the reason why we were seeing this error here, red underline here, was because we were not using remember. So let's use remember, because remember preserves the last value, or it will preserve the state of this counter variable across recomposition. So let's import remember here and let's run the app. So let's click this button. Now you can see the updated text. So this is how we create and update the UI in Compose. In this video, we learned about Jetpack Compose, declarative UI, introduction to composable function and recomposition. We also learned about preview tools. In later video, we will dive more deeper into Compose and learn about different composable functions. Thank you for watching this video, and please like and subscribe, and any feedback or comment would be really helpful. So please stay tuned for the next videos. Thank you.